All right, so here we're actually going to graph some of these quadratics. Remember to show your work, but to graph each quadratic using the provided table of values. So they give us a table of values, and some people may be thinking, well, let's just start subbing numbers in for x. We don't want to do this necessarily and see if it works out. And the reason why we don't want to do that, that works really well for linear functions, but when there's a vertex, that means basically there is a middle part of this graph, and it is the vertex. So we need to calculate the vertex first. So see pretty quickly here, a is -1. There is no b value since there's no x term, and c is 4. So using the vertex formula, we're going to take the opposite of 0. It doesn't really matter now what a is, because 0 divided by anything is just 0. So the x-coordinate is 0. So I'm going to put that right here, because basically that's the middle row of this table of values. And then I'm going to plug in 0 for x. And let's just see what we get here real quick. 0 plus 4, that's going to give us 4. So now this tells us which other points to pick for our t-chart. We want to pick a few points to the left of 0 on the number line and a few numbers to the right of 0 on the number line. Again, using 0 as that middle number was nice on this problem, but it won't always work out that way. So basically we need to plug in -3 for x. Again, be careful here. You've got to square -3, which is 9, but then multiply it by this other -1 out front. So that's going to end up being -3, -5. And let's just do this all the way down. We get 0. And we get 3. Now we do it to the other side. It's going to be 3. And some of you may see a shortcut. That shortcut is there's symmetry across the vertex. So you'll notice the y-coordinates on the outside are the same. The y-coordinates kind of on that next level are the same, and the y-coordinates right next to the vertex are all the same. So we're simply just going to graph these points, and we're done. And of course, it makes sense on this problem, since a is a negative value, that this is a frowny face or an upside down U. But on quizzes and tests, that's the type of work we're looking for. So let's try one more together, one that doesn't have quite as easy as a vertex at x equals 0. But this one, we're going to start it the same way. List your A, your B, and your C value. We notice the A value is positive, so what does that tell us? It's going to be a happy face. So we want to get the x-coordinate of the vertex. So we're going to do -b over 2a, or the opposite of b, over 2a. So it's 8 divided by 4. So the x-coordinate is 2. So that goes right in the middle. And then we're going to plug into 4x and see what that gives us. Now, a nice little shortcut, if you're in for shortcuts, and I know I am, is we can type this equation into our y equals, and there is actually a table feature that probably a lot of you know about, and hopefully you're using that. So you want to work more efficiently when you can. So if we type this in and then hit second graph, and then we see the table. And then we can see the vertex is clearly at the point 2, -11, which is what we would have gotten had we actually done the arithmetic there. But you can also see all of the other ordered pairs that we need. So 2, -11 is a point. Again, it doesn't necessarily matter what numbers you pick, but typically I just pick numbers that are 1 unit away on the left of the number line and 1 unit away on the right of the number line. And you can either plug those in for X, or you can use the graphing calculator. I would use the graphing calculator's table to get the rest of those values. So we see that 3 goes with -9, 4 goes with -3, so on and so forth. All right, so then you're going to graph the points. And one really neat trick that I use sometimes, and you see the vertex, the point 2, -11, goes off the graphs just a little bit. But since I know there is symmetry about the vertex, I know that there is a point that's on the mirror image side, basically 1 to the right of the vertex. This point right here is 2 to the left of the vertex. It's called the axis of symmetry, this vertical line. So that means I should have a point 2 to the right. And finally, this point is 3 to the left of the axis of symmetry, or the vertex. So that means its mirror image is 3 to the right. Again, you could have come up with that just by plotting the points. That's just another shortcut that I use sometimes. Just try to make it a nice, smooth curve. I want to encourage you to try that last one just to make sure you understand it and you've got it before you move on to your assignment today. Pause it, and I'm going to show the answer here in just a couple seconds. All right, so there's the work. And there's what the graph should look like. Oop, curve got off a little bit there. Remember, all of this work right here is kind of optional if you know how to use the graphing calculator efficiently.